Hello, everyone, and welcome to this super awesome VMware Code Power session. My name is Leon Stigte, and we'll get into a bit on Kubernetes and deploying your first application on Knative, essentially going from 0 to 60 with Knative. Uh, to start off with, today's actually a very special day. I mean, for everyone in the US watching, today, August 13, is National Prosecco Day. So right after this session, that's essentially what I'm going to do. Um, Today is also the day that in 1969 there was this super awesome ticker tape parade for the Apollo 11 astronauts. And what makes today even more special, at least from my point of view, is that today is my first VMware code session. So I am super thrilled to be here, and I definitely want to thank the host for having me on here. Now, as we get into the Kubernetes journey, as we dive into it, I actually want to take you on a journey. And how can you better start a journey than by using the amazing fairy tale theme of once upon a time in a land far, far away? So that's essentially what I'm going to do. And if you look at that, then in that time, this might have been your monolith built data center. A few decades ago, or actually even just in like the last 5 to 10 years, the de facto way to build applications was to build a monolith. There simply was no other way to do that. Um, to be fair, I am not against building monoliths. I actually believe that a well thought out monolith will always be better than a very badly created microservice architecture. And the thing just is that in that time, we never had the tools in order to do that. The technology to build something else simply wasn't there. Our networks weren't fast enough. Our CPUs weren't fast enough to handle multiple things communicating. We didn't really have good messaging protocols. Simply, they weren't as reliable, as optimized as some of the technology today is. So, looking at it from a developer point of view, we wanted to build software faster. We wanted to build better software faster. So over the last few years, the software industry really made it possible to build microservices. We built better networks, faster CPUs. From a VMware point of view, we obviously invented things like virtualization. We invented new messaging protocols like REST. We invented protocols like gRPC to really streamline the sending of messages. And the advances in network technology also made it possible to use that network bandwidth a lot more efficiently. Um, and because of that, we were actually able to build a lot more efficient applications. And then came the rise of Kubernetes in, I think it was, if I say it correctly, 2014, which actually made it possible to automatically make applications that we build and operate highly available and fault tolerant. So all of a sudden, as a developer, we had a lot more tools in our application toolkit to actually build sustainable and applications that could scale, that could stand the test of time. At the same time, microservices, so the whole idea behind building things that do one thing and do one thing very well, made it possible to deliver value faster. Um, as it turns out, the time to value, as a lot of people call it, is actually becoming the most dominant metric when it comes to business optimization. Everyone wants to make sure that you get to market faster than at least all of your competitors, to make sure that you have that competitive advantage. And these microservices made it possible to do that, to focus on the business logic, decreasing that time to value. And at the same time, a lot of companies, including VMware, really started to build new tools and new practices to support building those microservices. And essentially, a new or relatively new trend is emerging nowadays that really tries to decrease that time to value even further. And it is shifting the way that we build and connect applications. I mean, if you take a step back and look at the maybe not too distant future, we actually went from building applications that we connected to message buses, to brokers, sort of this service-oriented architecture style, where where we had to do a lot of the inventing ourselves as developers, we actually went to a completely different paradigm. We went to a paradigm where we're building event-driven applications that are based on APIs. And by the way, not just the applications that we build are event-driven. The infrastructure itself is also event-driven. It also has a bunch of APIs that you can connect with. I mean, the rise of things like infrastructure as code and the companies that are supporting that, they have their grassroots in this idea. And the way that we're building applications in a different way using events actually is to support a lot of different things. I mean, we want to see ourselves go from seeing the data to actually taking action on that data and maybe even automate that. We want to make sure that the value we want to deliver to our customers actually gets into the hands of our customers faster. Essentially, what we want to do is empower more users to build applications. And the reason I emphasize the more users has to do with the fact that as we make it easier to build applications, a lot of people that traditionally haven't been able to do so now actually can do that. In 2019, the CNCF, the Cloud Native Compute Foundation, did a survey where one of the questions was, are you using containers in production? And incredibly surprising to me, 84% of the respondents today are using Kubernetes or are using containers in production, I should say. Which is incredible considering that 3 years ago, or four if you count 2020, that number was 23%. So we went from 23 to 84% in companies using containers in production. And Kubernetes seems to be the de facto way to run those containerized applications. According to CNCF's Cloud Native Landscape, there are more than 109 tools to manage containers. And about 9 in 10, so 1 in 10 doesn't use Kubernetes, one or some form of Kubernetes. Having said that, there are challenges to using Kubernetes. I mean, it isn't as easy as everyone says it is. Using containers is actually tough. For example, if you look at complexity, 38% of the people that responded to that survey said that containers add at least a perceived feeling of complexity to the development lifecycle. So while we have this massively awesome infrastructure that allows you to scale, that allows you to build applications on top of it, that allows you to rethink the way you're bringing value to your business, we're actually adding a bit of complexity as well. So the question that I think as an industry we need to answer, how can we make this easier for developers? How can we make sure that the developers can really focus on what they do best? And that's essentially where I come in. I mean, I am one of those developers that wants to have an easier experience of using Kubernetes. And yes, I am very much a product manager, but I definitely love to write code as well. Slight caveat there, I do not like to maintain a platform. And that's sort of critical to what we're going to be talking about in the rest of the session. By the way, if you want to talk to me, I am at RedGates at pretty much any social media platform. So feel free to reach out with questions, comments, or whatever. And I probably should have said also feel free to put your questions in the chat function. So let's look at what we call the serverless operating model. I mean, it's an idea that was popularized by the team at AWS. And the definition that you see here on the screen essentially says that as you focus your engineering resources, you want to focus them on things that move the needle for your customers. I mean, it's essentially the buy versus build argument in a slightly different way, where you want to use managed services for things that as a core competency, you don't want to develop it. For example, if I don't want to have a core competency in managing my infrastructure, I go use a managed service. If my core competency isn't running a payment service, I go use a managed service for that, so that the developers on in my enterprise can actually focus on getting that customer experience, getting to market faster. So really getting the business value into the hands of customers. So does that make serverless a thing for Kubernetes? And I would say absolutely yes. If you look back at the CNCF survey, then at least 41% of respondents are saying they use serverless technology. And that could be hosted with like AWS Lambda, Azure Functions, Google Cloud Functions. That could be something that runs in your own data center on top of Kubernetes with something like OpenFaaS or Knative, which we're going to be talking about, or a combination of both, really making it a lot easier for developers to focus on the app. 34% says no, we're actually not using, or at least not yet planning to use serverless technology. And 20% says perhaps we're at least considering it in the next 12 to 18 months. Now, I alluded a bit to what Knative is. So how does Knative fit into Kubernetes? And as you look at it, Knative essentially builds on top of Kubernetes. It abstracts away the complex details, enabling developers to focus on the things that matter to them. It's built by codifying the best practices shared by successful real-world implementations of Kubernetes. And I really like this next part where it says that Kubernetes solves the boring but difficult parts of deploying and managing cloud-native services so you don't have to. And that, to me, that boring but difficult part is all about thinking that serverless operating model. I don't have to care about the networking as a developer. I don't have to care about all of the other things that make up the stack. I just care about writing my application. And that, to me, is incredibly important. So why would you build on Kubernetes anyway? Why did the Knative team, the Knative project, decide to build on Kubernetes? Which is an amazing question, and actually has a really good answer too. So the first thing is that Kubernetes provides this cluster operating system that's, I would almost say, ubiquitous amongst the enterprises. Having this operating system is really useful when you want to build a platform. Now, as I said, it is ubiquitous across enterprises, or at the very least, enterprises have a choice whether to not use Kubernetes. And it's actually a set of Lego blocks that you can assemble. And this is both, at least in my view, both a pro and a con. As you're a Kubernetes expert, then it's really easy to assemble all those building blocks into the thing that you want. If that is not your forte, then it's actually a bit harder to do. It's actually relatively tough to build your applications. And that, to me, is where Knative comes in. Knative helps you with assembling those Lego blocks into what it needs to be. So if you look at what's in that Knative box, there are essentially two parts: serving and eventing. Serving is all about providing a container image, which runs a single HTTP server and does a few things for you. It automatically scales to 0 when it's not in use. So when there's no traffic flowing through your system, you're not seeing any containers running, which actually makes it easy to reuse the capacity that you have on your platform. Second thing is it allows you to do version control and percentage rollout. So the A/B testing, the idea of blue-green deployments, which actually makes it super awesome to have multiple versions and gradually scale out where you want to have your traffic directed to. And it provides a single abstraction for developers, which we call a service, to interact with. So all of these things, these three super important components, is what is done out of the box by Knative. And the thing that as a developer I have to worry about is writing my code. Eventing, on the other hand, is something that provides the storage, routing, and delivery of event notifications over HTTP, giving you a bunch of pluggable storage mechanisms. It actually provides a pipeline and content-based routing So if you think back, if you have your grassroots as a developer or as an architect, whoever it is watching this video right now, if you have that background in things like message-oriented middleware and the service-oriented architecture, things like this will come natural to you. And this is what Knative brings to you out of the box. And the nice thing is that where in the past we spent a lot of time figuring out canonical data models and things like that, there now actually is a standard that does that. The messages are now based on a project that is called Cloud Events, which actually makes it a lot easier for different services to interoperate with each other. For example, GitHub, when it sends out a pull request webhook, it's actually a cloud event that it sends. And you can send your own cloud events as well. Now, that's great, but how does it actually work? And what we'll do is we'll walk through some scenarios, and then we'll actually go look at how that works in code, just to make sure that you get the conceptual idea, and you can sort of tie that to the things that you'll see later on screen. So first thing is scaling containers based on traffic. As I already talked about, the whole idea is that you want to scale the number of replicas that you have based on your request rate. Essentially, it allows a custom autoscaler, which is actually getting information from that queue proxy that you see there, and decides whether or not we need more instances of the user container. Think of it as a payment service that all of a sudden on Black Friday needs to handle a lot more traffic. Think of it as a service that that serves up images as your website gets really, really busy. These are things that you want to scale based on traffic, because that ultimately determines what the user experience at the end of the day is going to be. So for example, if we see that there are 3 requests and we set the concurrency to 1, so 1 request per container at a single time, then the pod autoscaler that Knative has actually talks to the Kubernetes API server, which then talks to the kubelet to add a bunch more pods, making sure that we can handle that traffic successfully. The nice thing is a thing that's called a bounded concurrency, and it actually means that you can run multiple requests, multiple concurrent requests in the same user container. This does mean, however, that you have to write your applications as threat safe. There are a bunch of fast products out there that aren't necessarily threat safe, so this is something that you have to consider if you set your concurrency to something else than 1. So in this case, my first request goes into to my user container, and my second request goes into the same one. Essentially having 1 container that handles all of that without the need to scale. And I can set that based on what I think is right for my application. This ultimately determines way down the line what the user is going to see as well. By far, one of my favorite use cases is scaling to and from 0. So essentially making sure that if there is no traffic, then nothing is running. So on this blue or Azure Blue, I guess, node, right now I only have the kubelet running, and there is going to come some traffic. So this HTTP request is coming in. It hits the activator. The activator now knows that there are no pods. There is nothing that can suffice that request. So the first thing that it needs to do is talk to the replica set, talk to the Kubernetes API server, which in turn talks to the kubelet to actually spin up stuff. And as that happens, the activator is actually able to forward the request to the actual container that then handles the request and sends the response back, assuming there is a response that needs to go back. And then as there is no traffic, for example, if all my requests are handled, then actually the reverse is also true. So what happens is all of a sudden we have this Knative controller that actually talks to that queue proxy, gets information from there. And if there is no more traffic, we can actually scale everything down and essentially return back to what it was before there was any traffic. So the whole idea scaling to and from zero is made possible by the idea of that controller working with the activator, making sure that there are a bunch of rules that determine when should I scale up, when should I scale down. I guess my second favorite feature, if my first favorite is the scaling to and from zero, is having the ability to do gradual rollouts of new versions. So if I have two versions, if I have my existing version that has been running in production forever, then I can say, you know what, I need this new version because we're doing a promotion or whatever, and that has to get 10% of traffic. So 1 in 10 of every request will be directed to that second container. All the other traffic is still pointing to the existing ones, and as more and more requests come in that will need to go to the other, you can actually start to tune either manually or automatically how much of that traffic should go to the other container. So you could split it 50-50. You could do a 25-75 split. It really depends on what you want to do, making sure that you get the best experience. Now, that all sounds great. I mean, slides are super awesome, or at least I think they are super useful. But how does it actually look in production? So I'm going to stop sharing the slides, and we're actually going to look at a bunch of, in this case, terminal windows. So I'm going to hide this for a second, and what I'm going to do is I'm going to create a brand new Kubernetes cluster first. So I'm going to use Kind. One of the reasons I actually like Kind is because everything runs on my own machine. And for this case, I use Kind version 0.81, which is, if I'm not mistaken, actually the latest version that is out there. Okay, and I'm going to create a cluster, and I'm going to do something specific with my cluster configuration. So this is the config that I'm using. And as you can see, there are some extra port mappings in here. So in this case, container port 31080 is pointing to host port, so the port on my Mac, port 80. And the reason that I'm doing that is at some point, and we'll get to that in a bit, I actually want to send traffic into my cluster. And since Kind doesn't have the notion of a load balancer, I have to use a node port, and I have to specify which port I need to use. Okay, so I'm going to create a cluster, and in case of Kind, it's Kind create cluster with the name, and I'm going to do VMware code because that's where we are today, and I'm going to use the cluster config that we just looked at. So that's right now going to ensure that the latest node images, and in this case, node means Kubernetes node. Node images are downloaded. It's going to prepare the nodes, write the configuration, start the control plane, and essentially make sure that all the things that a typical Kubernetes installation would have is now running on my Kind cluster. And Kind, for those of you who are not familiar with it, means Kubernetes in Docker, so K in D. Great, so that is ready. And one of the super nice things I actually want to show you is another tool called K9S, which is a Kubernetes logging service or logging tool where you can actually see all of those pods. So right now I can see that a bunch of things are going to come online, a bunch of things are already online. And as we go through the commands in order to deploy everything, you'll be able to see everything spinning up in that section as well. So let's continue. What I'm going to do is I'm going to make sure that my kubectl actually has the right context. So I am using the VMware code context, so that is great. And the next step is I am going to quickly show you the version so that you can actually see that everything matches. And right now I'm using 118, so that matches with the node image that I downloaded. And one of the other tools that I already have installed is the KNCLI, the Knative command line interface. And right now I'm using version 0.16 simply because that matches with the Knative version that we're actually going to install right now. So let me just do that. And what I'm going to do is I am going to use the Knative serving release. And the first thing I'm going to do is I'm going to install the CRDs, the custom resource definitions that my API server in Kubernetes needs to know about in order to make everything work. And as that is done, the second thing I need to do is actually run a bunch of, or another kubectl apply, and this is the actual core of Knative serving. And as you'll see, as this command runs, it's actually on the other side of the screen, creating a bunch of containers. So you can see the activator, the autoscaler, the controller, the webhook. So essentially the components that you saw in the slides. And what we'll do is we'll actually wait for all of them to be active or available in this case. And what I'm going to do is I'm going to set a timeout of -1 second. So that actually means it's going to wait indefinitely, which hopefully shouldn't be too long. In fact, I see that most of the stuff here is already running, which is nice. As we're well, technically it's already done, but the other thing I wanted to show you, I need this window, is another tool that you can use for that called Octant. And Octant, for the people who don't know, is actually a tool that that allows you to visually see what's going on in your Kubernetes cluster. So right now I pointed it to the current VMware code cluster, and I can actually see all the things that are in there. So if I go to, let's say, namespace overview, and right now in my default namespace, I don't really have anything. But in my Knative serving one, I should be able to see a bunch of things that are deployed. So I get from a graphical, from a browser, the exact same overview as I had within the other tool. So this is kind of nice, but let's also apply an Ingress router. And this ingress is needed in order to make sure that I can get my traffic from the outside into my Kubernetes cluster and ultimately into the Knative services. So I'm going to use Courier, and Courier is one of the Ingress gateways that has like the lowest footprint. It might not suffice for your use case, but it's the one that I'm familiar with. You can also use things like Istio, Ambassador. There are actually a bunch of awesome tutorials on the Knative documentation website that you can go and check out. So I'm actually going to wait till those are ready as well. So I'm going to use a very similar command. And if everything goes okay, it should actually be done really, really fast. And you can see I'm actually using a different namespace here. You know what? Let's actually use the K9S interface. And you can see that this is almost ready. It's waiting for that one thing to become ready as well. And that is right now the case. So we can continue with our deployment. First thing I'm going to do is I'm going to set my Knative domain to 127.0.0.1.nip.io. And nip.io is sort of a magic DNS that resolves everything that you put in front of it to that IP address. So in this case, whenever I send a request to that particular URL, it will actually redirect it to my local host. And I can actually check that that is working by just running a dig, and you can actually see that that stuff works, which means that I can use that URL to actually call my Knative services. And in order to do that, I need to patch the Knative serving config and pass in the domain. And just to see that that it actually worked, so I'm gonna discard my config map. And as you can see, this is the URL right here that we're using. Now, the one thing I need to do is update my Courier configuration to make sure that it listens on the right ports. So I'm going to use that node port that we saw earlier in the kind configuration and tie that to port 80. And this is the configuration that I need in order to make sure that the node port that it's going to open, that will accept the traffic and forward it to my services. So I am going to apply this YAML file, which essentially is going to overwrite the existing ones, updating the configuration. So then the last thing I need to do is make sure that Knative actually knows that it's going to get stuff from Courier. And let me quickly check if that was okay. And right here, we can see that the Ingress class is a created ingress.networking.knative.dev, so that works perfectly. Okay, now let's check. I mean, I can see on this side of the screen as well that all the pods are running, but let's see it in the command line. Let's say that you're not using K9s. The Courier system is up and running, and I kind of want to make sure that the Ingress is working too. So I want to check that service, and that service is running as well. Awesome. So how about we just go deploy an application, and that's what I'm going to do using the kn command line, and I'm going to do kn service create. I'm going to call it hello, which is obviously the most awesome name that I have ever given a service. And I'm going to use a ready-made container image. So what I'm going to do is a container image that the Knative team has created, which is called Hello World written in Go, as you can see by the container image name. And what I'm going to do is I'm going to add an auto scale window. And that auto scale window actually determines whether or not, actually, let me hit enter first. That auto scale window is actually going to determine whether or not it should scale up or down. It's going to determine whether or not it should add extra copies of the pod and make sure that it's routed accordingly, or it's going to say, look, I see no traffic in this case in 15 seconds. So what I'm going to do is I'm going to scale everything down, scale it to 0, so that you're not running anything else anymore. So that infrastructure that you were using for it, that you can simply reuse that for something else, whether it's a Knative service, whether it's something else. Those are the things that Knative takes care of for you. So rather than me having to figure out how that works, rather than setting up some super awesome autoscaler, Knative does it for me. So really, the only thing I needed to do is make sure that that my container is there, that my container is up and running. And it should take, last time I tried this, about 2 minutes. So in this case, only 1, making sure that it's available. And as you can see, the service is now available at http hello.default.127.0.0.1.nip.io. So how did that URL get there? Hello is obviously the name of the service as we specified it. Default is the Kubernetes namespace that you're deploying to, and right now I decided to just deploy everything to the default namespace, and then the rest of it is the Knative domain as we talked about earlier. So I am going to quickly list it so that you can see in a bit more detail what it is. So name, URL, the latest revision, which we're actually going to use. And you can see that there are a bunch of conditions. And if you looked over at the K9s side of the screen, you actually saw that there was no traffic anymore. So Kubernetes, or Knative in this case, the autoscaler decided it's no longer needed. I'm going to remove it. So let's actually do a curl. And what you'll see is that I'll get an answer, and you'll see that there's actually going to be a container spinning up. So as you can see, there is now on the other side of the screen, in the default namespace, a hello deployment. And as we go into it, you see 2 things. You see the queue proxy, you see the user container, and that queue proxy is the thing that talks to the autoscaler. Okay, let's quickly go back. Now this is nice. And what happens if I actually want to send traffic to different types of services? So the first thing I'm going to do is I'm going to add a tag to it. And I'm going to use the latest ready revision name and tag it with v1. Awesome. So as you can see, it's unchanged. It's still available at that specific URL. And if I now say that the environment variable that I want to specify, which is called target, which ultimately determines what we're sending back, is VMware code power session, then it's going to create a second a second revision. And that revision essentially means that I have something that I am never ever going to change, first revision, and now I'm creating a new one. So if I now do the curl, then you actually see that something that's going to come back is hello VMware code power session. That's great, and we can now list the revisions, and you'll actually see two. And the thing that you'll see is that one of them has a tag, one of them has traffic set to 100%, which essentially means that there is never going to be any traffic that goes from the outside to that first version of my service. So let's actually update that a bit. And let's say that I want to send 25% of traffic to that second version. And I want to send 75% to the one that I just tagged with V1. Now, in itself, the service hasn't changed, so that's why it says it's unchanged. And let's see the revision list again. And now it says that the traffic is split 25% to the generation 2, or the latest one that I created, and 25% or 75% to the first one that I created. And if I do a describe of my service, I can actually see that as well. I can actually see what revisions there were, what images were used. So I can actually use this a bit to start troubleshooting in case I need it as well. So let's actually send a bit of traffic in there and see that sometimes you're going to get the VMworld, VMware code power session. Sometimes you're going to just get a hello world. So I'm going to send 10 requests. Okay. And as it sends it in, hello VMware power session, hello world. And this is roughly a 25-75% split. Obviously, because you're doing it 10 times, you can't get a half response. So in this case, it sends me back 3 times the VMware code power session and 7 times the hello world. So that's actually a super useful feature as you're getting ready to deploy things. And you know what? Let's actually add another one. So first, that we'll tag this service, and we'll do a V2. That's awesome, and we will update it to say VMworld 2020, which is like right around the corner. And we'll tag that with V3. And what we're going to say is that 75% of traffic goes to V1, 25% of traffic goes to V2, and we're not sending any traffic to this latest version. So you can imagine that the idea behind this would be I'm building a website with a bunch of awesome services, and I don't want the one that responds back with VMworld 2020 to be already available before VMworld actually starts. So if I would do the revision list command again, it actually says that no traffic is going to go to that third version. So I can do that with the describe as well. Again, showing you the different container images. And if I actually execute that curl command again, then I should get a relatively similar response to the previous time I did this, making sure that there is no container that's going to respond back with hello VMworld 2020, simply because it hasn't started yet. Now, there definitely is a way to access it, and that's one of the reasons I added a tag, because I can actually send a curl request to here. And what you see is that it's essentially the same URL that I used pretty much the entire time. The big difference is I added the V3 hyphen in front of it. So that essentially says, you know what, send this to the tag version 3 of that specific service. And if I do that, you'll actually see that the response is hello VMworld 2020. And if you look over at the K9S side of things, you can actually see all of those containers being scheduled. And in the case of the former two, they're actually terminating already. So let's now switch back the traffic to the latest version for 100%, and then oh, and then run that revision list again. Um, so now 100% of traffic is going to that third version, and you can see that here as well. So the other two revisions that we had are not getting any traffic whatsoever. And now if I run that same curl command again, then what happens is that everything should respond back with hello VMworld 2020, simply because none of the other ones are getting any traffic, so none of them are being spun up either. Now this is great. Oh yeah, and obviously, just to show you that that I didn't lie, you can actually access the V1 service, so you can see it being spun up, and it actually returns hello world. Same applies to the V2, which then should respond back with hello VMware code power session. Now this is great, and this is essentially using a bunch of existing container images, but what does an actual image look like? I mean, what do I need to write as a developer in order to do something with it? So I'm going to create a Node application, Node.js, and this is essentially what it looks like. So I'm going to use Express. I'm going to use the port 8080 specific target. So I'm going to have that exact same message. And that's essentially it from a developer point of view. So you know what? Let's, instead of hello VMware code power session, let's say something else. Let's just say hello Knative. Save it, and this is the Docker file that I'm using. So essentially from Node, copy everything over, exposing port 8080. That port 8080 is the thing that connects my my proxy, that other container, to this container. So I'm going to do a Docker build, and I'm going to call it my awesome app, since it is my awesome app. So just building right now, and it is going to take a bit of time since I already run this this thing a bunch of times. It actually updated the cache layers, which is super useful, and I'm going to push that to Docker Hub, simply because I ultimately want to use it inside of Knative. If you're using another Docker registry, that's obviously where you should push. For example, if you're using a Harbor, if you're using Artifactory, then that's the registry that you want to push things to. So I'm going to now create a service that I'm going to call VMCPS, or VMware Code Power Session, with the image that I just had. So it's my awesome app. And I'm just going to do the same auto scale window. So what's happening is that right now my container, or my Kubernetes cluster, is reaching out to Docker Hub, getting back the latest version of my image, making sure that that essentially everything is still working. So that's going to take a bit of time, and as we're walking through that, let's actually look at how some of that stuff looks in Octant, because Octant to me is one of the most useful tools I've ever seen, and I've only come across it since I joined VMware. And it actually lets you introspect a lot of super awesome things, where I can go in and, for example, you obviously shouldn't be doing this, but if I want to take a look at the webhook in Knative serving, I can actually see the status. I can actually see the YAML file that was used to deploy, and I can actually start to make changes here and update the YAML in production. Now, I wouldn't necessarily recommend doing that unless you really know what you're doing. So right now, my service has been created, and as you can see, the latest revision is there. So let me actually quickly send a note to it, or a curl command, and what it's going to do is it's going to respond back with, as you can see, hello Knative. So this is super awesome from a Knative point of view. And let me actually go back to, oh, sorry, I didn't mean to stop sharing. I was going to say, let me actually go back to my slides, because the other thing I quickly wanted to talk about, and I'm not sure if we're going to have a lot of time to go over this, but it's the idea of eventing. And eventing essentially means that I'm getting some information and I want to send it somewhere that is not necessarily HTTP. So how are we going to get the event from the external system into my function? And that is exactly what Knative eventing does for you. And the first thing you need is what they call a source adapter. And for example, that could be like a GitHub adapter that gets the pull request and transforms it into the thing that you need to push. So this is the thing that listens to or receives the events. Second thing is that you need a broker. You need something that distributes everything across the different services. And ultimately, you need something that's called a trigger that provides actually content-based filtering, which is like a simple string matching thing where you can say if it's this event or if it's this type or any type of string matching, then send it to this function. Really making sure that only the events that match the filter are sent there. And awesome animation. So that's great too, but how can we use that? How can we see some of that in action? So let me actually go back to my demo again, and essentially go one up and apply the Knative eventing resources. So I'm going to apply the CRDs first. I think my screen sharing is stopped. Give me 1 second. Sorry, folks. I should have shared my desktop and not the other way around. So what I did is I executed the kubectl apply for the eventing CRDs. Second thing that I'm going to do, very similar to Knative serving, is actually apply the eventing core components. And as I'm doing that, let me just move this out of the way for a sec. You actually see that now there is a Knative eventing domain or Knative eventing namespace, which has an eventing controller, eventing webhook. And I kind of want to wait until those are completely done just to make sure that that everything is running that I expect there to be running. So great. So this is there, and I'm going to apply the third part, which is an in-memory channel. And channels are essentially the thing that that gets the events to the service. So I'm going to apply that, and I'm using the in-memory one, as you can see by the file name. This is great for testing. This is a really bad idea for production. If you're doing this in production, you really want to use something that's at least persistent. And okay, I need the memory controller and the memory dispatcher to be ready. And they are, which is awesome. And I'm going to add a broker. And I'm actually going to use an in-memory broker as well, a channel broker. And the channel broker essentially makes sure that all of the channels get their events, get their messages. That's great, and you can see a bunch more things being deployed. So I'm actually going to wait until those are ready, using a bunch of the same commands. Again, waiting until all of them are ready to make sure that the things I need in order to let my events flow, that those are available. Awesome. So let's label my namespace with Knative injection enabled. Then this is the thing that is going to make sure that Knative is going to inject the broker into, or enable the broker, I should say, into my namespace. And if I didn't want to, I could actually do that using a YAML file as well. And essentially what I'm doing is I'm going to create a namespace, or in my namespace default, I'm going to create a broker that I also call default. So I could do inject broker kubectl apply. And that essentially has the same effect. So let's actually look at a monitoring application that you can use. And what's happening here is a Python app that is going to accept all of the data and is going to essentially display it on the screen. So as you can see here, it's going to say Power Session event display, received message, and then the name of the message. I have a Docker file that in this case is based off of Python, and let me actually build it. I'm going to call it regex display simply because it's actually going to display stuff. Cool. And I'm going to push it to Docker Hub like I did with the others as well. Awesome. And just to show you what it looks like, I'm just going to run it on my local machine on port 8080, and it's going to start up now. And what I'm going to do is use one of my favorite tools called Insomnia, and I'm just going to send a request to it. So I can send in hello VMware, and it shows up in here. I know my little brother is watching, so I want to say hello to him, and so I can add his name, and it says hello Leslie right now. So that's all great, but ultimately we want to actually deploy it to our Kubernetes cluster. So I'm going to stop this, and I'm going to do the exact same thing. I'm going to create the I'm going to create a Knative service using that display image, and this time I'm going to set the minimum scale to 1. And what that essentially means is that no matter what happens, you can never scale to less instances than 1. So this is a service that's always going to be running, and because it's a display service that's really meant to show you things, that's obviously some good thing, which is different than, for example, the HTTP stuff that we were talking about earlier. So now I have an event display service, and you can see that it has a URL as well. And what I'm going to do is create an event source that's actually going to send messages to it. So in this case, what I'm going to use is what they call a ping source, and every minute it is going to emit a message that that is in this case hello world, hello VMware code Power Session, and I should have updated this with a uppercase S. So this is a good time to do that. Save it. Yes, absolutely. Event source YAML, and I'm going to apply it. And now that ping source is created, you can see it being created here. And let's actually go quickly into the event display user container. And as it starts up, as it starts to get ready to send messages every minute, in about a minute, we should see the actual message, the actual hello world or hello VMware display in this screen. This is always the nice thing about demos, that it always takes slightly longer than you expect. So as we're waiting for this to happen, let me quickly show you that I could have done this all through Octant as well. So let me just go in there, and you can see the event display here. And if I click on it, it actually shows me all the things that it needs. One of these super nice features, if you're starting to use Octant, is actually the port forward command. That actually makes it a lot easier to get data into your Kubernetes cluster. And by now that first minute has elapsed, so I can see the message hello VMware code Power Session. So if I just recap what we've been through in like the last 55 minutes or so, 0 to 60, then we created a Kubernetes cluster on our machine using Kind. We walked through what the installation of the various parts of Knative. We looked at some of the things it does, like the serving part with scale to 0, traffic routing, things like that. We looked at eventing and how you can actually receive events, how you can make sure that things do not scale to 0, and we actually deployed a few applications as well. So with that, I really want to thank everyone for joining me today. Let me quickly see if there are any questions. I see that there is one question here. What's a ballpark figure for latency when invoking a Knative hosted service for the first time, such that it goes from 0 instances to 1? It depends a bit. Depends on your network. If you have a okay, let me take one step back. What needs to happen is that your node, your Kubernetes install should go out to your Docker registry, get everything for you. So in my case, I am limited by my network bandwidth at home, which is why it takes a bit longer, as you could see. If you're on a corporate network where your Docker registry is located in a data center that's also hosting your Knative instance, then it's a lot faster. And you'll actually see that, and I didn't do that this time, I apologize, that if you would run something like a trace or a speed test or something along those lines in order to see how fast the response is, you can actually see that if you go from 0 to 1 instance, the second time around, it's actually incredibly fast. And the reason is simply because it's already cached on the different nodes. So I hope that answers your question. If not, just drop me a note on @redkits, and I'll make sure that either me or some of the super awesome people in the Knative community will get back to you with the answer then. So that, at least as far as I could see, were all the questions. I really appreciate everyone for dialing in. Appreciate everyone for spending this hour with me. Thank you very much.